Out there, in the vast, silent dark between the stars, something is drifting. It's not a planet. It's not a star. It's a colossal, dark sphere wrapped in a faint, menacing red glow. Across its surface, colossal bolts of lightning flicker without a sound. This is a cosmic failure, an object caught in the lonely space between planets and stars. It's called a brown dwarf. It's too massive to be a gas giant like Jupiter, yet too small to ignite the nuclear fires that power a star like our sun. It doesn't shine, it barely glows, a dying ember in the galactic fireplace. But if you were to fall into one, you would discover it is anything but gentle. Tonight, we're going to make that descent. From a distance, a brown dwarf seems unimpressive, dim, reddish, and cool compared to the brilliant fury of a true star, but looks can be deceiving. Most brown dwarfs pack the mass of 10 to 80 Jupiters into a similar-sized ball. When you crush that much gas together, gravity becomes an invisible, terrifying monster. As our imaginary ship gets closer, the first thing we notice is the radiation. The cold of space gives way to a blast of infrared heat flooding our senses. This is not a cold place. It only looks that way from light years away. Up close, it's a furnace. The dark ember is growing, transforming from a point of light into a massive, brooding world. Now we reach the upper atmosphere, and it is a vision straight out of hell. We're met with thick, swirling clouds unlike anything in our solar system. Forget water vapor. The clouds here could be made of molten iron droplets and grains of silicate minerals, essentially liquid rock and hot sand, and the winds, they could be screaming past at thousands of kilometers per hour, whipping these metallic clouds into planet-sized storms. Through the glowing haze, lightning flashes, not just small sparks, but superbolts of electricity that dwarf anything seen on Earth. This is Jupiter's storm system, turned up to a nightmarish extreme. The temperatures here can easily top 2000 degrees Celsius, hot enough to vaporize most metals. This isn't an atmosphere you fly through, it's one you melt in. And now, the fall begins. Our ship starts to drop. The gravity indicator on our dashboard begins to climb relentlessly at the cloud tops. The pull might feel familiar, maybe a few times Earth's gravity, manageable. But as we descend deeper, the crushing reality of a brown dwarf sets in. More and more mass is now above us, as well as below us, and the pressure starts to rise at an exponential rate. Unlike on Earth, there is no solid surface waiting for us at the bottom. There is no ground to land on. There is only deeper, denser, hotter gas. Within minutes, the pressure outside surpasses anything humans could ever engineer a machine to withstand. First hundreds of atmospheres, then thousands. The air around our ship becomes so dense it's more like a liquid. Our descent slows to a crawl, as if we're sinking through cosmic molasses. Our ship's hull groans, buckles, and then implodes, crushed into a microscopic speck. Of course, a human body would have been obliterated long before this point. But for the sake of science, our imaginary probe continues its journey downward. Because the physics is just getting interesting. Deeper and deeper we go. The pressure is now millions of times that of Earth's surface. Here, even the fundamental nature of matter begins to change. Hydrogen, the most common element in the universe, can no longer exist as a simple gas. It's compressed so violently that its electrons are stripped away, and it becomes a bizarre substance known as metallic hydrogen. We are now sinking through a planet-sized ocean of electrically conductive fluid. This swirling, metallic ocean generates a magnetic field of unimaginable power. Trapped within it are radiation belts far more intense and deadly than Jupiter's. Any electronics, any complex chemistry would be instantly fried. And still, there is no ground. We are just sinking through an endless sea of fluid that gets ever denser and hotter with every kilometer we fall. Finally, we approach the very heart of this failed star. In the most massive brown dwarfs, the core temperature and pressure can briefly, just for a moment in cosmic time, become high enough for a special kind of fusion to occur. Not the hydrogen to helium fusion that powers the sun, but the fusion of a heavier element called deuterium and sometimes lithium. For a short while, the brown dwarf flickers with a bit of internal fire. It tries to become a star, but it's not enough. The fuel is too scarce, the core not quite hot enough. The fusion reactions sputter and die out. The outward push of energy fails to overcome the inward crush of gravity. Gravity always wins here. The object never truly ignites. From this point on, its fate is sealed. Slowly, over billions and even trillions of years, the brown dwarf will simply cool down and dim, a cosmic ember fading to black. So what happens if we just keep falling? Is there a center? The probe sinks endlessly. Unlike a rocky planet, a brown dwarf has no sharp boundary defining its core. The density just keeps increasing. The gas has long since become a supercritical, fluider, strange state of matter that is not quite liquid, not quite gas, but has properties of both eventually. If you could survive the journey, you would approach a central core. Scientists theorize it's likely made of compressed rock, metal, and other heavy elements left over from the object's formation, a tiny seed in a giant's heart. But you will never see it. The pressure and temperature are so extreme that they would dismantle any known material, atom by atom, long before it ever got close. And here's one of the most surprising things about brown dwarfs. They shine, not because of ongoing fusion like the sun, but because they are still radiating the immense heat generated during their initial collapse. They were born hot, and they are still cooling off. So when you see a brown dwarf's faint glow, you are not seeing the light of a star being born. You are seeing the light of a star that failed, slowly dying over trillions of years. Fading, cooling, becoming darker and darker. If you could wait long enough, an unimaginable stretch of time, this failed star would become nearly invisible. It would cool down completely, becoming a cold, dark sphere known as a black dwarf, a ghost in the cosmos, incredibly hard to detect. The galaxy may be filled with these objects, hidden masses wandering through the void between stars. Some could even pass relatively close to our own solar system, and we wouldn't even know they were there until their immense gravity started to pull on the outer planets, betraying their presence. The universe might just be crowded with these burnt-out almost stars. A brown dwarf is what happens when nature almost succeeds. It gathers enough matter to be more than a planet, but not quite enough to be a sun. It is a monument to cosmic ambition that fell just short. If you fell into one, you wouldn't hit the ground. You would simply vanish into a nightmare of pressure, heat, and endless crushing depth. A powerful reminder that in space, even a failure can be enormous. Thanks for joining us on this journey into the abyss. If you enjoyed this cosmic deep dive, be sure to subscribe for more adventures into the unknown. See you next time.